One, we will solve this today's LeetCode problem. So the question is combination sum 2. It's a LeetCode medium. Let's see what the question is asking. So we have given a collection of a candidate numbers, candidates, and the target number target. Find all unique combinations in candidates where the candidate numbers sum to target. Each number in the candidates may only be used once in the combination. The solution set must not contain duplicate combinations. Okay. So basically, what we need to do, we have given a candidates, right, and a target, right, and we need to find all the combinations, unique combinations, such that the sum of the candidates which we choose is equals to the target one. So basically, the question is like a coin sum problem, right? It's just like a coin sum problem. Here, there's that it changed candidates to coins and the targets changed to some changed to target, right? It's just like a coin sum that we need to choose some of the candidates value and which sums equals to target, right? And we need to return all them, but uh, we can't add. We don't want duplicates, duplicate solution. What does it mean duplicates? If we see the first example, here the one is present at two times, right? So one possibility is 1, 2, and 5, right? With 1 1, right? So there can be also a possibility that I can make this answer as from second one, right? Like 215, right? I can also make this, but this is a duplicate, right? So we don't want this, right? We don't want this, right? That's what this meaning is. The solution set must not contain duplicate numbers, right? So how we will, so basically how we will find this, all the possibilities of unique combinations from the candidates, right? So basically we need to we need to we need to return the values. We need to return the all the values which whose sum, all the values whose sum equals to the given target, right? Given target. So basically then it means I need to try each and every number, each and every combinations, each and every combinations to find that, right? Right. And if we see the constraints here, the constraint size, the candidate's length can be equal, size of candidate can be equals to 100, right? Can be equal to 100. And if I want to make you all the combinations with this 100, that can take maximum of 2 to the power 100. Why? Because either I will include it, because I need to use recursion, right? I need to use recursion to check each and every possibilities, that for sure. For to check each and every possibility possibility, right? But that's gonna and what we do in recursion, we, yeah, either include the current element or or exclude the current element, right? That's what we do, right? And in either including or excluding, for each number we have two options, and total the 100 can be possible. So that's why it can be possible that it is can be 2 to the power 100, right? But 2 to the power 100 is very high, right? Its time complexity is very high. It will definitely gonna give you TLE, right? But how will we do that, right? But how will we do that? The first thing to note that we need to find unique combinations, right? It means if there are duplicates present, we don't need to take that in consideration. So one thing is for sure. So what we will do, if there are several numbers of 1111 is present, so we need to take consideration of only one, right? Only one, right? Only one, right? So one thing is for sure, but that these things, this will reduce some time complexity, right? In this 5 I can reduce to one only, right? So this will help us to reduce little bit of, to reduce little time complexity, right? Right. Okay. One things to note also, right? That if you see the target value here, the target is only 30 till 30, and candidates is from 1 to, okay, okay, candidates is given from 1 to 50, 50, right? It means whenever the target is, whenever the target is achieved, we don't need to check further, right? We don't need to check if target is achieved already, then we don't need to check further, don't need to check further, right? Also, if candidate candidate is candidate I is greater than the target value, then we also don't consider that element, we also don't consider the element, consider that element, consider that element, right? So these things we need to consider in our mind, right? To while solving this problem, only then we can simply solve this problem by recursion, because ultimately I need to use recursion for sure, because I need values to return. I don't need count, I don't need nothing, I really want these values. So for finding these values and returning these values, I need to has use recursion and backtracking for sure. There is no any approach will be done either use DP or anything. This needs to be done using recursion plus backtracking only, right? Because we need actual values, right? That's why we need to use this for sure, right? But we can reduce it, because 2 to the power 100 is for sure given TLE, right? So we need to do something that it can reduce a little time complexity so that it don't give TLE. So one thing is to achieve that there can be duplicates, so we will reduce, we will consider only one elements if there are duplicates present. The second thing, the target value is 30, so if target is achieved, so we will don't need to go further. And also candidate value, if candidate value is greater than target, it means it will not it should not be considered in that element, right? These things should be clear, right? Now, one thing is to note that what we will do. So for excluding and including, what we'll do, we start from every number, right? We start from each number, and we either consider it or don't consider it, right? Either we include it or exclude it. That's what we do, right? Either we include or exclude. That's what we do, right? What we would the changes be done, right? So the first thing to know that I have told you that we need to consider for only one to reduce the duplicates, right? So for checking duplicates, what we can do, we can use sorting, right? We can use sorting. We will sort the candidates. We can sort the candidates, right? Sort the candidates. So if I sort the candidates, let's take the first example itself and make you understand properly. If I sort the candidates, what it will happen, it will okay, this will be 5 here. What would happen, it will write like this, it goes like this, right? Now if you see, duplicates come duplicates group together at one thread, right? Can all the candidates which are the same group together at itself after sorting, right? So what will happen when I start from this zero part, when I start from this zero part, let's make start from zero. 0 1 2 3 4 5 6, right? When I start from zero, so either I will include the zero or exclude the zero, right? And this is the target. Let's target as 8, right? Right, and make that. So if I want to include it, so I plus 1, right? This is I, which is a 0, right? This is 0 index. Let's just write like this, I comma target, right? So if I include this, it's good I plus 1, or it is 1. And also if I include this, I need to decrease, I need to minus it from my target because I have included it, so it will become 7. But if I don't include it, it is still goes I plus 1, but it will be no change to it, right? What happened now? Now for both have, for both, okay, sorry, yeah, for both I have still have two choices for this, right? Either I include the first part, this one number, or not. But before including, what will I check? Before including the current element, that's where the we will handle some cases. Before including the current element, i will check I will check that whether this current element should not be, should should not be, must not be equals to the previous element, right? Because we don't want duplicates, and if I take this one again, it will give me again one suppose I have taken first one, it give me 125 and 167, and if I include the second one, it will same give me 125 and 167. But we don't want that, right? We don't want that, right? And order doesn't matter here, right? Order doesn't matter. So what we'll do, we will check that whether this current element is same as previous element. So this one is same as previous element, so we don't, we will skip this, right? We will skip this. So we will skip this simply, right? We will skip this. We don't take this. Same goes for this. We skip this, right? So means after this 17, it will not go to this oneth part, right? This oneth part is not, it can go to second part, but it will not go to oneth part, right? So what we will do, we will now shift to 2, right? Now we will shift to 2. Now we will shift to 2 because 1 is skipped, right? Now the part is this one is shifted to 2 now, right? Because 1 is the first index will not be considered skipped, we will go to second part, right? The first is skipped, we will go to second part, right? So I'm just changing this 1 to 2 because we have a skipped one, right? Now this 2 can be included or excluded, right? If I include it, this will become 3, and the second part is 2, it will become 5, right? If I exclude it, this become 3 and this become 7, right? The same goes for another part, 3 and 5, right? Now either include 3 or exclude 3, right? Depends on what is the values. So if I see this is a 5, so if I include it, it will become index 4, and this is become 0 because I have included it. And if I exclude it, this become 3 4, and this become 5, right? Now we have got a target 0, it means we have achieved some values. And what I have achieved, this 0, this 2, this 3, and this 4 index values. And what is that? So along with that, I am storing the characters. And what, where I am storing the characters? Here. That the first part is 0. Okay, sorry, the first part is 0 index. So here, along with that, this is the index, right? This is the index, and this is a temp value, which this is a vector, right? This is the array vector where I'm including elements, right? So here, the the array element is what? The array element is 1 because 0 I've included it, right? Here in this case, 1 along with the second part, which is 2. Here 1 with along with the second along with the third part, which is 5. So 1 2 5 is an answer when target is 0, right? Now uh, let's make this as a simple here, and this 3 7 should be here for this, right? So this 4 5, this 4 5 is still we have target, right? So let's make this 4 5 here, right? 4 and 5, right? I'm just making making the recursion tree to just make a simple explanation to you that how is it working, right? Because for beginners level, you need a recursion tree to understand how is it working. So this is 4 and 5, fourth index and 5 value. So 4 index, the 6 is value. So either we include it or exclude it. If I include it, it will become -1. So target is less than 0. It means after this we don't need to do that, right? So if target is 0, why will I move it, right? Why will I move it? And why will I take this consideration? Why will I take into consideration of 6? Because it will be greater than the target. That why it comes less than 0. It means we don't need to consider this. We don't take this as an answer. Now can we move to, if I don't exclude it, so this will be 5 and this will be 5 again, right? When we move to 6, the same thing will happen to this. The same when we go to 5, this same thing will happen. Either you include the sixth element, fifth element or not. Fifth element is 7, so if you include it, this will become again -2. Again you will exclude it. So basically the base case, what would be the base case, right? The first base case, the first base case is target. If target is equals to 0, we will have a array of solution. See, target is 0, so we have 1 to 5, so we will consider this as a solution. We will take this as a solution, right? Second test case, if target is less than 0, we will return from that. Why? Because the sum of solutions which we have is greater than the target, right? So we don't need to do that. Third, when the length of this candidate I is achieved, right, at the boundary position, so we will return from that. So that three are the base cases, right? And what we do at each step, we are storing elements such that when I hit target zero, I can include my solution in that, because ultimately I need to solve this, right? So this is how we solve this problem basically, right? So this is how we solve this problem. And each step, what we check, that it should not be previous elements, and it should not be, and the target value should be greater than zero in that case, right? That's what we do, right? So basically, it's a 2 to the power 100, but we can handle it by changing this, and it will not give it TLE, right? And how this backtracking? So when you hit this, when you hit this 1 to, sorry, when you hit this 1 to 5, you will return from that, you will return from here. So when you return from here, this 1 to 5 changes to 1 to, so this 5 needs to be deleted, so we will pop this out when we move to its parent element, right? Same, when we move to its parent element, this will need to pop it out to 1, right? That's here the backtracking is achievable, right? So we will see in the code, right? So let's just implement it, right? So yeah, start from candidates. So let's just make it as a c dot size. Now what we need to do, we need to define a vector to store all the solutions. That would be a 2D vector for sure. And also I will define a temp value. Why temp value? To store the solutions, temporary solutions. And I will call a solve function c, sorry, for 0, start with 0, the target, and this c value, which is the candidate, right? Now what we will do, I will start from 0, sorry, this is I is equals to I, and this will be the target, and this will be the vector end, right? And c, right? Now what we will do, we will just find this size of candidate. Okay, the first thing to note that I need to check for each and every element, and also I need to check whether we can skip it or not. Okay, the first thing is to sort the element. Why to sort? Because I don't want duplicate elements, so I will first sort it beforehand, right? Before starting recursion, I will sort the candidates, right? I will sort it. Also, what I will do, I need to check for each and every element that whether we need to include it or exclude it. So for that, what I need to do, I will start iterating from j till n for each and every possibilities of I, because I need possibilities with this I. So what I will do, I will check for each and every possibility, right? So whether I need to include it or not. So this temp will store the values. So first value that I have included it, if I include it, I will store it and store the value here, right? Now if I take in this value, I need to move from this here. So this will be j plus 1, because I have included it, this jth part. So I need to move it from here only, after one index after, because I've included it, right? So the target value should be c minus cj, right? Because I've included it. Also, second part is excluded, right? Second part is excluded. So for excluding, what we need to do, this solve function go to recursion and somewhere hit the base case and return from after that here we need to delete, pop back this, the last element which I have pushed, because see, in this 1 to 5 is here, it hit the base case, it moves to its parent. So when it's moved to parent, this temp would be need to be same, the 5 will not be here in 1 2, so it needs to be popped back because we have inserted it, right? Because either I include it or don't want to exclude it. So when I hit this 1 to 5 and get the back, so I need to pop back this so that I can move to this excluded part, that is 4 5 wala part, right? So that's why I need to pop back, right? So this is including and this is excluding. So this is a backtracking, here this is a backtracking, right? Right. Okay, one thing to correct, that we need to reduce the duplicates, right? We need to don't consider the duplicates, right? So for reducing duplicates, what we'll check, we will check that whether this j should be, they should be greater than I, and this Cj should not be equals to Cj minus 1. Why j greater than I? Because if j is equals to I, this will be equal, right? If j is equals to I, this can be go to out of bound, right? Because j can be 0, right? So j should be greater than I, or Cj. So on Cj is equals to Cj minus 1. So what we will do, we will continue in this. We will skip this index for now, right? If it is equal. Now the base case we have, what will the base case is, this will be the base case, right? If target is 0, if target is 0, it means I got my answer, I have my solution in my temp, right? So what I will do, I will just push back this temp to my 2D vector and return from here. Second base case, if target is 0, less than 0, or I is less than greater than equals to 1. Target less than 0 means the number is greater than the solution, total solution summation of the temp values are greater than target, so we don't need to consider that. Or the candidates is over, the number of candidates is over, so we will return in that case, right? So one thing to note, why haven't I write like this, why haven't I write like this? Because because it can happen that, because I am I am decreasing this target from my CJ, and and increasing my index value, right? So it can be possible that I can be greater than equals to n, but target is also 0, right? Target is also 0 and I greater than equals to n also, right? In that case, it will not insert my temp values in my answer if I write this below, after this, right? So it will return up from here. That's why I need to return, I need to write it before, right? I need to write it here, right? That's why I need to write it here, because at last case it can be possible that I is equals to n and target is also 0. So in that case, I will there this temp values will be left out, right? So that's why I need to write it beforehand after this, right? So this is how we solve this question, and at last we will return the answer. So let's just run this. Hope you understand this implementation. I think there will not be compilation error, but still, what will, okay, time limit exceeded. Let's debug this now. uh, answer dot pushback j greater than I. Okay, j should be plus plus, right? Let's run this again. Yeah, we have passed the sample case. Let's submit it. It's taking a lot of time. Okay, yeah, we have passed all the test cases, right? So basically, what will happen? We have included, excluded, just a just as something to reduce this time complexity from 2 to the power 100, to reduce it to include sorting, don't include duplicates number, and also when target is less than 0, we will return that, we will don't need to check for that. So if you don't do this now, this will give TLE for sure. Do you want to see that? See, if you don't do this, this will give TLE after submitting, of course, because these are the very small elements, right? For this it will not give TLE. Okay, it gives TLE for what? Okay, for this case, I've included this case. So see, there are, this is not an 100 numbers, right? This is something like 30 to 40 numbers, and this is give TLE, right? So that's why this is needed. Target less than 0, right? Because target is only 30 and 2.30 is achievable, right? So that's how we will solve this problem. So basically, time complexity would be definitely O of 2 to the power n, right? And n is, so we are not taking duplicates, so n is number of unique elements, unique elements. Okay, unique elements present in candidate, present in candidate. Also it unique candidates can be 100 and can be 100, so it must be to the power 100, but the target value is only 30, right? So that's why it is not, uh, target value is only 30, so that's why it is not a problem. And also space complexity, so if you consider this answer array which we are returning as an extra spaces, so it's a O of n square. But mostly times we don't do this, right? We don't consider answer vector as an extra spaces. We consider, we consider only the spaces which we are using for solving this problem. which is the temp value. And in temp value, at most, it can happen that all the elements of candidates is possibilities of summation of the target value, so it can go to maximum of O of n, right? Also, if you take auxiliary stack space, which we are using recursion here, so it can also go to maximum of O of n, so ultimately it is O of n, right? So this is how we solve this problem. Hope you understand it. Thank you so much. Bye bye.